Hello guys, welcome to learning microcontrollers. In this video I'm going to show you how to interface a cheap 16 into 1 LCD with a PIC16F877A along with the counter, how to run a counter on it. So this is the LCD I'm talking about. It's a very cheap 16 into 1 LCD having 16 pins, but it has no backlight. This LCD do not have a backlight. It can display 16 characters in this way. Red ones are first 8, green ones are second 8. See, total 16. Total it has 16 and they are divided into two rows. Red one is row 1 for PIC configuration and green one are the row 2. So whenever you program it, you take the first 8 digits as row 1 and the second 8 digits that are green one as row 2. That's how you will do the programming. So this is our PIC16F877A DIL version having 40 pins. This is the LCD we are gonna use right now, and this has 16 pins from left to right, 1 to 16. To adjust the contrast, we will need a 3-pin variable resistor 10 kilo ohm value to be used with the LCD. It also has 3 pins. Now let's do the connections. Pin number 1 and 5 of the LCD goes to pin number 1 of the variable resistor, then to the common ground. Pin number 2 is the adjustable pin. This goes to pin number 3 of the LCD. Pin number 3 and pin number 2 of the LCD and 3 of the variable resistor are shorted and goes to common 5 volt supply. Pin number 2 is the VDD pin of the LCD. It will receive 5 volt, and pin number 3 of the variable resistor from the PIC16F877A VCC pin. So in this way we give 5 volt to variable resistor and 5 volt to LCD. Pin number 4 is the RS pin. You can use any digital input output pin of the PIC16F877A for this. Any available pin, any digital input output pin. I am using C0, that is pin 15. For enable I am using C1. For D4 data pin 4 I am using C2. For data pin 5 C3, for data pin 6 D0, and for D7 D1. Rest of these pins, pin number 7, 8, 9, 10 are for 8-bit mode, while we are using 4-bit mode. 15 and 16 are for LCD backlight, but this LCD has no backlight. In this program I am going to show you how to use this LCD. I will demonstrate this by, first of all, the LCD will display learning and then microcontroller one time. Then in the forever loop it will display count start, and then it will say 0 to 100. It will start counting from 0 to 100, and once it's done it will display done, and then it will start over again. So guys, let's get to the MikroC coding. This is our MikroC for PIC. So let me zoom in. Okay, you go here, file, new project. You get this window. Here you write the name of the project, LM16x1 LCD. PIC16F877A is the one I am using right now. Use 20 MHz crystal. That is what I am using. Okay, then we get our window. Then here you go to the left. Here in the library manager you go to LCD. First of all we will need to initialize the LCD. For that purpose go to LCD. Here you have an example of commands for 4-bit initialization of LCD. You copy this, go back, place it above the one-time loop. You place this like this. Then there is RS pin defined as B4, but we had just connected it to C0 as shown in the presentation. C1 for OEN. For D7 we are using D1, D0 for D6. Then we have C3 and C2 for D4. Similarly for directions do the same. For RS we have C0, C1, for EN, D7, D1, D0, C3 for D5, and C2 for D4. In this way our parameters are initialized. Now initialize the LCD pins. Use this command LCD INIT, then give some initialization delay. 1 second will be great. So here is our initialization delay of 1 second. Now since our LCD is initialized, now we can go and send values on it. Okay, first of all we will do is that LCD has a cursor in start on the screen. We remove that cursor. We do not need the cursor. So you go to LCD CMD. Here you have this command LCD CMD clear. Just paste it. You paste it here. Then again you go there, library manager. You go to LCD CMD. Here you have this chart. In the chart you can see there are certain commands like LCD blink cursor on. There it is turn cursor off. You copy this, go back to the code, you place it inside the bracket. So now it will clear the cursor. Cursor will no longer be on the screen. given initialization delay. Now we also clear the LCD as well. Again go to LCD CMD, there is a command called LCD clear here. You copy it, now you place it here and you give some initialization delay like this. See, LCD cursor is removed and LCD is now clear for writing. Now to write something on the LCD, you go to this, get this command LCD out. Here it is. You copy this, go back to the program, you place it below. Here LCD out, that is row, first row. Start writing from first column. What we want to write is learning 1 2 3 4 5 6 7 8 digits, and first row can support 8 digits. So these 8 digits will be displayed here, given initialization delay of 100. Okay, it will display learning. Okay, we display it for 1 second, 1000, and then we clear the screen for second value, that is microcontroller. As LCD will be cleared. Again copy this. Now microcontroller is a big word, will be need to be divided. Micron on the left side and controller on the next side, and that will be second row, like second 8 digits on which controller will be displayed, and first 8 digit on which micron will be displayed. As you can see, as I had told you in the presentation, this LCD's configuration work this way. 8 digits are first row, the next 8 digits are second row. So in this way microcontroller will be displayed. Again we clear the LCD, and now the LCD is clear. Now we can go to our forever loop. To get to the forever loop, you write while 1 starting bracket, and this is our ending bracket. Here we go. Now inside this we need to display, again copy this, we display count start, count on the first 8 digits, and start on the second, like this. It will be kept on displaying for 1 second. Now we clear the LCD again. As shown in the presentation, this will be displayed. Okay, let's make it smaller. Count start. Okay, now we will display another value as I had shown you in the presentation, 0 to 100. 0 to 100. It's 1 2 3 4 5 6 7 8 digits. It can be displayed on the first row. Spaces are also counted. Now what's gonna happen, that we need to go for a counter. For that I use a do while loop. Do this, and here we will write the condition while some condition and then ending semicolons, and in that we take a variable. First of all, initialize a variable for the counter. Write like, okay, I am using float, and variable I use is count1. And to display the values on the screen, we cannot display floats directly. We will need to convert it to string. Count11 is the char, and it has like 4 digits. It can store 0 1 2 3 4 5 digits. It's an arrow of 5. So let's start the counter. First of all, we give it a value, initial value as equal to 0.0. So our counter has an initial value 0.0. We do this float, we convert the initial value float to str, that's 0.0, which will be displayed, that is count1 to count11. Okay, the value in the count1, that is 0.0, will be converted to count11, and given initialization delay of 50 will be good. Now we display it on the LCD, or you can simply copy this, LCD out 11, and enter this variable count11. Value in this will be displayed here, that is 0.0, and now we need to increment it for the counter to keep on going. Count1 is equal to count1 plus 1. See, now this count1, which is at 0, will be incremented by 1.0. See, count1 plus 1, given initialization delay 20 will do fine. Okay, now it's incremented as well. Now we simply need to clear the screen. For that, use the LCD clear command. Here it is. for the new values to be displayed. Clear, make it less, 30 will do fine. So in this way our total value is done. We need to display this for a bit longer, like for 200 millisecond is enough. This delay will define the speed of the counter, how fast it runs. Now we need to display it like count 1. When it ends is that count 1 must not increase 100, maximum value is 100. So in this way it will not increase 100. If you want a count of 200, you just change this value. Now since our values are displayed and LCD is also clear, now we display our final variable strings that was done will be displayed on the screen, and LCD will be cleared. It will be kept on displaying for 1 second, and then the LCD will again clear up. And once the LCD is clear, now the count 1 is at 100 value. We need to you can say give count initial value. So we do this, we write count 1 is equals to 0.0. again count is brought back to initial value, that is 0.0. give a delay 100. You can write it here or you can write it here as well, but this is fine. So when the code ends, count 1 will be returned to initial value. It will restart, it will start from 0 again. So let's this is the total code we are going to use right now. Here we go, we build it. To build the code, click on this button. Okay, LCD. Okay, we forgot the I here. See, it's INIT. Okay, now we build again, see what happens. Okay, it's built successfully. Now we get to the hardware. This is our hardware. As you can see, this is the LCD 16:1 LCD I'm talking about, having 16 pins, and this is PIC16F877A. Connections are as shown in the presentation. So we first build the code again. In case it's not built, click here to build the code. Now you go here, select your code from imported. LM16:1 is the code's name. Okay, here it is. Open it, click on write. The code is being written. As you can see, let it write up and see what happens. Okay, the code is written. Now we give 5 volt from the PIC3. Just click on this on button. Here we go, the 5 volt is being provided. It is learning microcontroller, count start 0 to 100. See, it's counting. Okay, the speed, you can increase or decrease the speed by simply changing the delay. Let's change the speed. It seems to be slow, but let's complete it up. See, 48, 50, 62, 66, 70s. See, it's incrementing by 1. I had used +1, so it will increment by 1. So it's done, it displays done, and it starts over again, and again it starts from 1 to 3. Now let's increase its speed. See, again I go there, I increment it. See, there in the loop we have this delay. I make it 100, it will halve the speed. I make it 50, it will increase the speed by great number. Our code is working fine. I'm just show you how to change the speed in case if you want it. See, to increase the counter speed, we simply go here, click on write. The code is being changed. See, the code is changing. It's writing again. Let it write. Okay, again, see, learning microcontroller, count start. See, now it's fast. If you want to increase or decrease the speed, simply change the delay. So guys, I wish you guys learned something from my videos. Thank you very much for your time, and have a nice day until the next video. Bye.